Hi everybody, we are moving on to learning targets 9 and 10 in chapter 1. So we're going to talk more about circle equations. So we need to talk about completing the square, and I'll get to the reason why in a little bit. But first of all, let's just remember what completing the square accomplishes and why we do it. So if we were to look at this squared binomial, or this one, any of the three, that really means that times itself. So x plus 3 times x plus 3, x minus 8 times x minus 8, etc. If you were to double distribute that out or FOIL it or whatever, however you learned it, you would end up with this. Okay, so same thing over here, same thing over here. This is what you're going to end up with. What patterns do we see now? Well, we're going to see that the linear coefficient and the constant term, that this is this divided by 2, so half of this term squared is that third term. So I'm just going to back this up 1 second so you can see that process again. We're seeing that like 6 divided by 2 is 3, and 3 squared is 9. 16 divided by 2 is 8, 8 squared is 64. 14 divided by 2 is 7, 7 squared is 49. So the constant term, this guy, is half of the linear term squared. So if we are going to determine whether or not these are perfect squares, just so we can realize what these things look like, you're going to look. Is this divided, can I get this from this divided by 2 squared? So what is 2 divided by 2? 1 is 1 squared 2? No. 6. 6 divided by 2 is 3. 3 squared is 9? Yes. 4. 4 divided by 2 is 2. 2 squared is 4. Fantastic. Okay, so that's how you figure out if it's a perfect square. We are going to need to complete the square. And again, I'm going to tell you in a little bit, but I'm just getting you to that step. So we're doing baby steps up to it. So to complete the square, this is actually what we're doing. We're completing the square by filling in the question mark in all of these. So we need to divide by 2. So 12 divided by 2 is 6. And then square that value. 6 squared is 36. Divide by 2, we get negative 3. Now be careful here. Negative 3 squared, I don't care what your calculator tells you. When you square negative 3, it means negative 3 times negative 3, which is a positive 9. Positive 9 divided by 2 is 9 over 2. When you square that, you get 81 over 4, or a decimal approximation. I'm just showing you what you would get as a fraction. So here's where you did it in algebra. In algebra, you would get something like this, and you would say, okay, this is not a perfect square because 2 divided by 2 is 1. 1 squared is not 13. So we're going to move this constant term, and we're going to create a different one. So we move the 13 over by subtracting 13 from both sides. And then we leave 2 spaces. We leave 2 spaces because it's an equation and it needs to remain equal on both sides. So I divide 2 by 2 and I get 1. 1 squared is 1. So 1 gets filled in on both sides of the equal sign because, again, it's an equation. We need to make it remain equal. The whole purpose of doing this is so you can write it back to that first slide I talked about as a binomial squared. Because if you were to factor this, you would get x plus 1 times x plus 1, which is the same thing as x plus 1 squared. In algebra, you kept going. In this case, it would be an imaginary answer because you can't have a square root of a negative. But I was just showing you how to complete the square. This is what we're trying to do in geometry. So let's just try one more time. Here, the constant is already over to the right, so I don't have to move it. So I would just leave 2 blank spaces. 10 divided by 2 is 5. 5 squared is 25. So 25 would go both in. And again, the entire purpose of completing the square is to write it as a squared binomial. So you write this as x plus 5 squared. It's always this b term divided by 2. If this were a minus 10, this would be a minus 5. So why am I doing this to you? You know, it's not just for fun, I swear. In geometry, we're talking about circle equations. It's not always going to be in standard form. Just like with a linear equation, when you have to get y by itself to get it in standard form of slope-intercept, you have to get circle equations in standard form. So this is the thing that you will hear me say over and over and over. Okay, to set this up, you get your x's together, you leave a space. You get your y's together, you leave a space. You put everything else on the other side, and you leave 2 spaces. That is the process you need to follow. And now we have it set up to complete the square. Because we have 2 variables, we need to complete the square 2 times. 4 divided by 2 is 2. 2 squared is 4. Again, it's an equation, so I have to keep it equal on both sides. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Again, I'm putting it on both sides. Now notice, again, the entire reason we complete the square is to write this trinomial as a binomial squared. So this gets written as x plus 2 squared This gets written as y minus 1 squared. The addition comes down, and then we add on the right. Notice we are now in the standard form of a circle equation. That is why we do this in geometry. So now at this point, if I had asked it, you could have told me that the center was at -2, +1, and the radius is the square root of 13. Okay, moving on to B. So again, put your x's together, leave a space. Put your y's together, leave a space. Put everything else on the other side, which it already is, and leave 2 spaces. -8 divided by 2 is -4. -4 squared is 16. It goes in both spaces. 10 divided by 2 is 5. 5 squared is 25. It goes into both spaces. The entire reason we did that was to write both of these as binomial squared. So we have x minus 4 squared coming from this completing the square process. We have y plus 5 squared coming from this completing the square process. And over on the right, when I add those together, I get 31. That is what we're doing, and we're going to keep doing it in class. So have a great day, and I'll see you later.